All right, good afternoon, everyone. Here we are. Um, Today we're going to look at some of the mechanics with respect to these thermoplastic processing methods, and most of them will be utilizing what's known as an extruder screw. All right, and it consists of I've blown up these pictures. These pictures actually came from the slides that I sent you yesterday, and so I wanted to kind of go over some of the details with you. But this is an excellent, probably one of the better slides of all these that we've seen, depicting the functionality and what's in place with respect to these extruder type screws. This is basically an Archimedes type screw rotating here. And it consists primarily of the screw itself and then the barrel here, all right? And then we have some other auxiliary items here. Of course, we have the hopper, which is where everything starts because the plastic pellets come into this system vis-a-vis the hopper. And let me explain to you a little bit about what these pellets represent. All thermoplastics, of course, as you well know, can change their status, their phase from liquid to solid, solid to liquid, just based on temperature. And so many of these different thermoplastics have a variety of different melting temperatures, and whether or not they're crystalline structure or amorphous structure, meaning whether or not they have a specific melting temperature or just more of a softening range. And so that would obviously need to be known prior to going through any kind of thermoplastic processing method. So they come to the extruders. This is just an extruder, which basically is just going to put out a continuous cross-sectional, just like in extrusion, just a continuous cross-sectional part here, which they're calling the extrudate. But it's also used in the injection molding operation in the machine, and we'll go into that detail later too. But the principles are the same with respect to how this extruder, screw and barrel work and function. So the pellets, these plastic pellets, the thermoplastic pellets, come to the manufacturer here, and come in little tiny beads, almost look like little tiny beads, maybe at the most, maybe an eighth of an inch diameter, usually somewhere between a 16th and an eighth of an inch in diameter, tiny, tiny little beads. And they come to them, and they first come into the machine, like I said, through this hopper. Now, you have to understand the chemistry behind this because these, as you well know from your material science days, of course, is that these pellets have a tendency to be hygroscopic, which means they have a tendency to absorb moisture just right out of the air, humidity. And so if they absorb any moisture, and you know, some polymers are more prone to that than others, then when they enter into this barrel here and they begin to melt, or what we call plasticize, we're going to be in excess, usually in excess of 350 to 500 degrees, somewhere in that range. Well, obviously, water boils at 212, so that's going to become a basic issue. So prior to any processing of any thermoplastic material, which we're going to call effectively just referred to as resin, has to be thoroughly dried. And so there are always dryers and heaters in the before it gets into the hopper, so that these plastic pellets will have absolutely zero moisture potential in them. So at any rate, they come into this extruder screw and barrel assembly, and the extruder, here's the extruder screw itself, and then the barrel, and there's a feed section, a compression section, and a metering section. And we'll talk all about that, but I want to get into specifics of actually what's taking place here in just a moment and show that to you, and the mechanics of what's going on and how we create the actual polymer, what they're calling here a polymer melt. So and this screw is basically again an extruder screw, but it's basically a typical metering type screw. So it meters a certain amount out each time it turns, and it has this utilitarian uh, functions of just conveying solids, melting the polymer, and then metering of that melt flow out through this die here. All right, so let's get into the actual kind of mechanics of some of this, and I think I'm going to have to turn the camera a little bit, so bear with me while I reposition the camera here so you can see it a little bit better maybe. I think I can leave it right there for the time being. But this is a close-up of the extruder screw and barrel. And of course, this is representing the barrel here, the outside, and then it has obviously an inner diameter. And then here is the actual screw itself. And the screw is made up of what we call flights. All right, these are these angled ridges that rise up above. And then there is the pitch here, okay, which is the distance between these two flights. So as you can see, visually see, as you go around the circumference of this white area is going to be represented as a circumferential volume actually. And as you notice here, you might notice that you see this volume is rather large back here in the feed section, this little area, this little volume here, but it gradually gets smaller and smaller.